Dear students, as you know, the industrial pharmacy class, mixing chapter we have started, and through the lecture we will discuss the mechanism and equipment used for liquid mixing, recalling from a previous lecture in which we have studied the basic concept of mixing. Apart from basic concept of mixing, we have also discussed the importance as well as the number of equipments used for the solid mixing, linking with the yesterday topic. Today we will discuss the various mechanisms involved in the liquid mixing and importance of mixing equipments in the liquid mixing. Dear students, the main objectives is to learn about the mechanisms involved in the liquid mixing and to learn about the various equipment utilized for the liquid mixing. First of all, we will discuss in detail the different mechanism of the fluid mixing. One of the mechanism is bulk transport, which is the movement of large portion of material from one location to another location in a given system. Recalling from the definition of mixing, where two or more than two components are necessary. In this case, if we have fluids and the materials are two or more than two, then the movement of the large quantity of that particular fluid will be resulted from one place to another place in that particular system. And for this purpose, rotating blades and pedals are used. The second mechanism of fluid mixing is termed as turbulent mixing, which is highly effective mechanism of liquid mixing and resulted due to the turbulent flow, and the turbulent flow ultimately results in random fluctuation of the velocity of fluid at any given point within the system. This random fluctuation of the fluid velocity is responsible for highly effectiveness of this type of the mechanism of mixing. Fluid velocity at a given point changes in the three direction, as you know, the three dimensions, that x, y, z. The third mechanism is termed as laminar mixing. That is the mixing of two dissimilar liquids through laminar flow. Laminar flow means the applied shear stretches the interface between them. Interface is the bond layer between two phases, and this type of mechanism is appropriate for liquid which require moderate mixing. So if we have a liquid needing moderate type of mixing, then the laminar mixing mechanism is preferred one. The fourth mechanism is termed as molecular diffusion. Molecular diffusion means the mixing at molecular level. and at molecular level the molecules diffuse due to thermal motion. Thermal motion is involved in this type of mechanism of mixing. The thermal movement is responsible for diffusion. Now in this part of the lecture we will discuss the basic concepts of the mixing equipment for fluid. A number of equipments are used for the fluid mixing, but the basic parts of the equipment are comprised of two parts. First one is container and the second one is mixing device, which is also termed as impeller. You can see a block diagram on the screen that comprises of impeller, that is a mixing device in the middle, and one of the container or tank in which this impeller is stored, and this impeller is further connected with the motor or drive at the central shaft. And baffles are also in this container. The tank having inlets and the liquid or fluid that required mixing is introduced by using tank inlet. And the impeller, that is the mixing device that is for the mixing of the liquid, which is controlled by the central shaft, that is having the motor connectivity. The mixing device, which is also termed as impeller, it is further classified into three types. There are three types of the mixing device or impellers based on shape and pitch, including propellers, turbines and pedals. Remember that propeller is one type of the impeller, as well as turbines and pedal. Impeller is a broad term, it is used for the mixing device, and propeller is one of the mixing device. There is no need of confusion between these two terms, impellers and propellers. Impeller is mixing device and propeller is one of the type of impeller. Propellers, that is a mixing device, consists of a number of blades. You can see on the screen. On the number of blades, generally 3-bladed design is most common for the liquid mixing. You can see on the right side of the screen that is a block diagram of the 3-bladed design, and 2-bladed design is also there, and the 4-bladed as well, but generally the 3-bladed design is most commonly used for the liquid mixing. The blades may be right or left-handed depending upon the slant of their blades. 2 or more propellers are used for deep tank. In case of deep tanks, where a large quantity of fluid is to be mixed, when one propeller is insufficient to mix the liquid, so it is recommended to use 2 or more than 2 propellers for mixing of liquids in the deep tank. The size of propeller is small and may be increased up to 0.5 meters depending upon the size of the tank. If the tank size is larger, then definitely we have to increase, and we have to prefer the larger size propellers, and the size may be extended up to 0.5 meters. It is rotated at different speed. A small size propeller can rotate up to 8000 rpm and produce longitudinal movement. We will discuss the different types of flow patterns in this lecture as well. Advantages of propellers. There are different advantages of propellers, including that it is used for the mixing of liquid when high mixing capacity is required. Secondly, it is effective for liquid having maximum viscosity of 2 Pascal seconds, or in case of slurry that having up to 10% solid and that solid having fine mesh size. Moreover, effective gas liquid dispersion is possible at small laboratory scale. If we are interested to disperse gas into liquid, it is possible by using propellers at small scale. There are certain disadvantages, including that propellers are not normally efficiently used with liquid of viscosity greater than 5 Pascal second, such as glycerine, castor oil. Because of the greater viscosity, that is more than 5 Pascal second, propellers are not effectively used. It is one of the disadvantages of the use of propellers for mixing. The second disadvantage is the production of vortex by using a centrally mounted vertical propeller. If we use centrally mounted vertical propellers at that position, the vortex formation will be resulted. We will also discuss what is meant by vortex formation and how the vortex formation is prevented. The second class of the mixing device is termed as turbines. Turbines consist of a circular disc. You can see on the screen at the bottom a circular disc. It is the first one. On the right side you can see the circular disc as well. One is a circular disc to which a number of short blades are attached. On the left side you can see these short blades are curved, while on the right side you can see the circular blade to which the short blades are attached, which are straight, and 6 blades are attached to the circular disc at the left side, while at the right side the blades which are straight, these are also up to 6 blades are attached. The diameter of the turbine ranges from the 30% to 50% of the diameter of the vessel. If you have container, and then what will be the diameter of turbine used for the container? We will use 30 to 50% of the diameter of the vessel turbine, and the turbine rotates at a lower speed than the propellers. The speed of propeller is high, and I have told you that small size propeller can rotate up to 8000 rpm. In case of turbines, rotation is low. Speed of rotation is very much low compared to propellers, and that is about 50 to 200 rpm. Flat blade turbine produce radial and tangential flow. but as the speed increases, these flows will be definitely affected, and the radial flow will be dominant. In case of pitch blade turbine, if we use, then it will produce axial flow. We will discuss radial tangential and axial flow pattern as well in this lecture. Near the impeller zone of rapid currents, high turbulence and intense shear is observed. Shear produced by turbines, that is one of the mixing device, can be further enhanced using a diffuser ring. A diffuser ring means stationary perforated ring which surround the turbine, and this diffuser ring is responsible for shear production enhancement by the turbine by using a diffuser ring. Advantage of turbine include that having shearing forces greater than that is used by propellers through the pumping rate is low, therefore suitable for emulsification. Because of the shearing forces are involved in the emulsification process, it is preferred to use turbine rather than propellers because of the greater shearing forces development. Turbines are effective for high viscous solutions with a wide range of viscosities up to 7 Pascal second. In case of propellers, which is not recommended for high viscosity, that is viscosity greater than 5, but for high viscosity up to 7 Pascal second, turbine can be effectively used for mixing. And low viscous materials, a large volume turbine create a strong currents which spread throughout the tank, destroying stagnant pockets. When the stagnant pockets are destroyed, it means that the movements will be favored and the mixing will be facilitated. Apart from these advantages, turbines can handle slurries with 60% solids. Up to 60% solid content having slurries can be mixed using the turbines. Turbines are also suitable for liquid of large volume and high viscosity if the tank is buffered. The third type of the mixing device is termed as pedals. A pedal consists of a central hub with a long flat blades attached to at vertical position. Two blades or four blades designs are common. Sometimes the blades are pitched and may be dished or hemispherical shape and have a large surface area in relation to the tank in which they are used. Pedal rotates at a low speed. The speed of rotation is 100 rpm per pedal. You can see on the screen the pedal, the two bladed design of the pedal. Pedal are used a number of manufacturing of pharmaceutical products like antacid suspensions. One of the antacid suspension that is available in the market under the name of Mucane, comprising of magnesium hydroxide and calcium hydroxide by the white pharmaceutical. Pedal are also used in the manufacture of agar and pectin related purgatives preparation, and in the preparation of antidiarrheal mixture, for example bismuth choline, that is one of the antidiarrheal mixture, or the preparation of these products, and some of the other products, but these are some of the examples of the products where pedal are used and their manufacturing. The advantages of pedals over the other type of the impellers is that vortex formation is not possible with pedal impellers because of the low speed mixing, while in the other impellers the high speed mixing is involved, and which results in the vortex formation. The disadvantage of pedals include mixing of suspension is poor if we use pedals, but this deficiency may be overcome by using the baffled tanks in order to ensure the mixing of suspension efficiently. There are certain terminology we have used in the discussion related to the flow patterns during the mixing. There are three flow patterns. First one is tangential component or circular, second one is radial component, and the third one is axial component or longitudinal or vertical component. These are the flow patterns during mixing of liquid we observe. Tangential component, you can see on the diagram, that's acts in the direction tangent to the circle. You can see a circle, that is the tangential component or circular acts in direction tangent to the circle of rotation. If it is rotated clockwise, then in this direction to the circle a tangent will be formed around the impeller shaft. This is the impeller shaft and it is rotated clockwise, then the flow in the direction tangent to the circle of rotation around this central shaft to which the impeller is attached. If shaft is placed vertically, tangential flow follows a circular path around the shaft and creates a vortex in the liquid near to the circular path around the shaft, that is the rotating shaft. It creates a vortex, that is circulatory pathway of the liquid. The second one is radial component that acts in direction vertical to the impeller shaft. You can see that is the impeller and vertical to the impeller shaft. This flow pattern will be followed. Excessive radial flow takes the material to the container wall, then material falls to the bottom and rotate as the mass beneath the impeller. And the third type of flow patterns during the mixing of liquid, it is axial component or longitudinal or vertical, as the diagram shows on the left and right side, that acts in the direction parallel to the impeller shaft. Parallel to the impeller shaft, inadequate longitudinal component causes the liquid and solid to rotate and layers without mixing, and adequate longitudinal pattern is best used to generate strong vertical currents, particularly when suspending solids are present in the liquid. These are the different types of flow patterns during the process of mixing of liquids. Now in this table you can see that impeller pipe we using when the flow component is absorbed. In case of propellers, axial flow pattern or component is absorbed. In case of turbines, axial or tangential or both are absorbed, while in case of pedal, radial and tangential. And if we use pedal with pitch, then radial, tangential and axial flows pattern will be experienced. One of the terminology that we are using in this lecture, that is vortex formation. That is one of the drawback and some of the impellers. That is a strong circulatory flow pattern sometimes manifest into formation of a vortex near the impeller shaft. Near this impeller shaft, certain times strong circulatory flow pattern is experienced near the impeller shaft, and shaft is placed asymmetrically in the tank. In this case, a vortex can be formed. In case when the blades in the turbines are arranged perpendicular to the central shaft, in this case also vortex formation is resulted. At a high impeller speed, that is one of the drawbacks of the impellers, the vortex formation is resulted. If we use unbuffeted tanks, then in this case the vortex formation is resulted. Disadvantages of vortex formation, that not only reducing the mixing intensity but also reducing the velocity of impeller relative to the surrounding fluid, and the mixing efficiency will be affected. When vortex reaches the impeller, air from the surface of the liquid are drawn and air bubbles are produced in the formulation in the particular solvents or fluids which we are going to be processed for mixing. Air bubbles in the fluid can create uneven loading of the impeller blades, and then trap air causes oxidation of the substances in certain cases. Now, how we can prevent the vortex formation? The vortex formation can be prevented by using a impeller should be in any one of the position, then can avoid symmetry such as off central. If we use rather than at the central position, the impeller is placed at other position, or if we use inclined shaft like this one, or side entering like this one, to avoid the vortex formation, we will place the impeller at any other position to avoid the vortex formation. Or in some cases it should be deep in the liquid. If I use deep in the liquid as well as here instead of at a separate position, the vortex formation will be prevented. Buffered container, if we use the buffered container like this one, that is a buffered one, these are the buffered, instead of this one that is not buffered but here inclined shaft are used to avoid the vortex formation. If we use this type of container which is buffered one like this or that, in such case impeller can be mounted vertically at the center, but the buffered container are used in order to prevent the vortex formation. Two or more impellers are mounted on the same shaft where greater depth is required. and this system is known as push and pull mechanism. Push and pull mechanism is one of the prevention mechanism or using two or more impellers. The bottom impeller is placed about 1 impeller diameter above the bottom of the tank. It creates zone of high turbulence. Equipment used for fluid mixing. There are a number of equipment used, including a jet mixer, flow mixer, or line mixer, or pipe mixer. Shaker mixer can be also utilized for the fluid mixing, turbine mixer, and as well as pedal mixer. Mixing of miscible liquid and suspension. Mobile liquid with low viscosity are easily mixed with each other. So in this case, solid particles are readily suspended in mobile liquids, although the particles are likely to settle rapidly because of the low viscosity when mixing is discontinued. While in case of viscous liquid, which are difficult to stir and difficult to mix, but the sedimentation rate of the suspended particles are low because of the high viscosity of the liquid. Mixing of miscible liquid, like any manufacture of emulsion, that is carried out in the pharmaceutical emulsion, and the equipment used for preparation of emulsion is known as emulsifier, also known as homogenizer, as it results in the formation of emulsion. Fine emulsion can be prepared in two stages. First stage, coarse emulsion is prepared by using one of the following process, like equipment used for that purpose: wishboard, mechanical blender, hand homogenizer, porcelain mortar and pestle, milkshake mixer, propeller, and the baffle tank. Sometimes the fine emulsion is also formed in this process by using these equipment directly. Fine emulsion is resulted. If fine emulsion is resulted, there is no need of the second stage. If coarse emulsion is prepared in this first stage, then we will further subject the coarse emulsion to the second stage, to the homogenizer in the second stage, to get a fine emulsion by using the following process, like Silverson emulsifier, colloidal mill, or Rapisonic homogenizer. Silverson emulsifier is one of the popular equipment used for emulsification, and its principle is that it produces intense shearing forces and turbulence by use of high speed rotors. Circulation of material takes place through the head by suction produced in the inlet at the bottom of the head. Circulation of the material ensures rapid breakdown of dispersed liquid into small droplets. As you know that emulsion is a biphasic system consisting of two immiscible liquids in which one phase is dispersed throughout the other in the form of small droplets or globules. But the circulation of the material, in this case, that ensures by rapid breakdown of the dispersed liquid into small globules. And this piece of equipment consists of a long supporting column and a central portion. Central portion consists of a shaft which is connected to motor, which is responsible for rotation. At one end it is connected to motor, and on the other end it is connected to head. Head carries turbine blades, that is the mixing device, and blades are surrounded by a mesh or screen, which is further enclosed by a cover having opening. Uses of Silverson emulsifier, that is used for emulsification in creams of fine particle size, and the advantages include it is available in a variety of sizes to handle the liquid ranging from few milliliter to several thousand liter, and it can be used for batch operation as well as for continuous operation, but we have to incorporate into a pipeline through which the immiscible liquid flow. Disadvantages of this piece of equipment is that in certain cases occasionally there is a chance of clogging or blocking of pores of the mesh, which can block the process of emulsification as well. References for consulting preparation of this lecture, you can consider the theory and practice of industrial pharmacy, Lakeman, and Art of Pharmaceutics, the Science of Dosage Form Design, second edition. Thank you all for your attention.